Welcome. Now we are discussing about the inference, right? So inference regarding a single mean. Okay, a single mean means what? We consider a population. This is the total population in which we take a particular sample. Okay, from the sample we calculate the sample mean and sample variance or the samples standard deviation s square or s. We calculate these things, and with which we try to see with the selected sample we are trying to generalize things for this population. Okay, whether the population mean, like with the sample that we have taken, can we say anything about this population mean, provided this population standard deviation is known. If it is unknown, we just approximate this one as the sample standard deviation. Okay, and what is the size of the sample that we have taken? Okay, if the sample size, we generally take it as n, and if n is bigger than or equals 30, we consider this as a large sample. In this case, with the help of standard normal distribution, that is z, we perform all the calculation. When n is smaller than 30, we consider this as a small sample. So in this case we are in a need for some other distribution which is more or like the standard normal distribution. So assuming the normal population, we have a t statistic, something called t statistic, to deal with the small samples, and this has a parameter nu, which is nothing but n minus 1. In both these cases we have some level of significance that is known as alpha, that is the probability of type 1 error. Okay, so probability of type 1 error means what? Null hypothesis is true, but still we reject it. What is the probability of this occurrence? So these things are given. Okay, now that our population is a single population in which we take a sample and we performed all this calculation. Okay, now in this video we are going to discuss about the inference concerning two means. So whenever we say inference concerning two means, we do not have a single population, we are having two populations. So from population 1, the population mean is denoted as mu1 and the variance is sigma 1 square, and similarly for population 2. Okay, here from the two different populations we have taken two different random samples of size n1 and n2. Okay, so for these independent samples we calculate the sample means and sample variances. Okay, and now that we are going to consider this x1 bar minus x2 bar. Okay, again this one can be treated as a sum of normal variates when these quantities are large enough. Okay, sum of normal variate is again a normal variate, so with which we can very well find out the expectation and variance using the usual properties of expectation and variance. They happen to be these values. Okay, now with which we proceed further. How we are going to test the hypothesis? Okay, so here what we are going to test is that we will test that these two we have taken two different population, and from which we have taken two different samples, right? So the average, that is the mean, does not bear any significance. Like what I'm trying to say is that they are almost the same. That is what we try to say. Okay, the sigma. Okay, supposing their mean differ by some a quantity. So in this case we have sigma. Sorry, we have delta. Suppose uh, two population have no significance significant difference in means. Suppose this is the case, then our null hypothesis would be mu1 minus mu2 is 0. That is mu1 and mu2 are equal. Okay, now that initially we are assuming both n1 and n2 are large enough, so which means what, we are going to make use of the z statistic. Okay, here what is the variable, what is the thing that we are going to test? X1 bar minus x2 bar is the variable to which we are going to apply the things. Now that suppose you take uh, x to be x1 bar minus x2 bar. This is a normal variate. Okay, with mean mu1 minus mu2 and variance sigma 1 square upon n1 plus sigma 2 square upon n2. Now that if you try to normalize this, what do we do? X minus the mu value divided by variance of x, that is the standard deviation, that is what we need, right? So x is simply x1 bar minus x2 bar, isn't it? Okay, and what is the expected value? That is mu1 minus mu2 divided by under root sigma 1 square upon n1 plus sigma 2 square upon n2. That is the test statistic that we have. Okay, here this mu1 minus mu2 we have taken it as delta. Suppose we are discussing about the there is no significant difference in means, we will have 0 in this place, right? So this is the test statistics with which we are going to work. Now we have assumed that this is the null hypothesis. Then what could be the alternate? It can be this mu1 minus mu2 may be bigger than delta, smaller than delta, or not equal to delta in simpler case. So just like we had the several cases in the previous testing of hypothesis, here also we have the same. Okay, suppose population variance are unknown, we use the sample variance as the estimate of population variance. Okay, now let us get into the problem directly. Okay, in this problem we are given that in an elementary school examination in spelling, the mean grade of 32 boys was 72 with a standard deviation of 8, while the mean grade of 36 girls was 75 with a standard deviation of 6. Okay, now that we need to test the hypothesis at 1% level of significance that the girls are better in spelling than boys. Okay, so first of all let us try to squeeze out the information that is given in this problem. Here n1 is 32 boys, isn't it? And for them the mean is 72 and standard deviation is s1 is 8. Similarly n2 is what? N2 is 36. Okay, and x2 bar is 75 and s2 is 6. Now that what is our test statistic? Test statistic z is given by x1 bar minus x2 bar minus delta upon sigma 1 square upon n1 plus sigma 2 square upon n2. Okay, and we know this value 72 minus 75. And what is this delta value? This should be varying to a certain extent. Here the question is to test the hypothesis at 1% level of significance that the girls are better in spelling than boys. Okay, now that we need to write out the hypothesis, right? Okay, what would be our null hypothesis? So that is our h naught is, so generally we don't need to do anything to justify null hypothesis, isn't it? So we would say they have the same average. Okay, against the alternate hypothesis h1 is, supposing this n1 is related to boys, all these things are related to boys and all these things are related to girls. In that case we are asked to check girls are better in spelling. So this mu1 is smaller than mu2, that is mu1 minus mu2 is smaller than 0. So it means what? Our delta value is 0 divided by, we do not know sigma 1 value, so we just make use of the available value itself. So when you perform this calculation, you would get minus 1.732. Okay. Now that from the table, we need to calculate Z alpha, that is Z 0.01 is 2.33. Okay. So now that we need to, now we will have to check whether this belongs to what category. Okay, so we have mu1 minus mu2 smaller than 0, that is smaller than delta. This is the case. So we need to check whether z is smaller than minus z alpha. Here what is z value? That is minus 1.732, which is smaller than minus 2.33. This is what we need to check. Okay, but this is not the case. So therefore what? Actually this implies our z is not smaller than minus z alpha. Therefore, H naught, the null hypothesis, is accepted. That is the difference between the sample mean is not significant at 1% significant level. At 1%. Okay. So with which we come to the conclusion that girls, okay, so let me put it in other words. We cannot conclude that girls are better in spelling than boys. And remember, here you cannot come to a conclusion that boys are better in spelling than girls. That is not the conclusion here. Here we are testing whether girls are better in spelling or not. Okay, so girls are better than boys or not. This is what we have tested. Okay, and the hypothesis that we have accepted is they are more or less the same. Okay, that is the hypothesis that we have accepted. Okay, so when you conclude the statement, just be careful with what you are concluding at the end. Okay, moving to the next example. Here it is said that a random sample of 100 bulbs produced by company A had a mean life of 100 1190 hours with a standard deviation of 90 hours. Next, we have taken a random sample of 75 bulbs by company B had a lifetime of 1230 hours with a standard deviation of 120 hours. Now that we are asked to check whether there is a significant difference between the mean life of two brands at this level of significance. Okay, again, we will consider the informations for company A and company B. So the sample size. So N1 how much? It is 100, whereas N2 is 75. Okay. Next is sample mean, that is x1 bar, which is 1190, and x2 bar is 1230. Okay, next is sample standard deviation, that is s1, which is 90, and s2, which is 120. Okay, and here our alpha value is 0.05, isn't it? Okay, now let us denote mu1 and mu2 be the respective population means. Right? Now that we need to test the null hypothesis, h naught, which is mu1 minus mu2 is 0, because no significant difference. This is what is specified in the problem, isn't it? Okay. So against alternate hypothesis, which is h1, there is no significant difference, isn't it? Okay. At 5 percentage level of significance. Okay. Moving further, here test statistic is what? Z is x1 minus x2 divided by under roots s1 square upon n1 plus s2 square upon n2, isn't it? If we substitute the values, it is 1190 minus 1230 divided by under root 90 square upon 100 plus 75 square upon 120, which is minus 2.4209. Okay, and from the table we get z alpha, that is z alpha upon 2. Here we need to calculate. Why so? Because here we have this mu1 minus mu naught not equal to 0. Delta value is 0 here. So here the condition that we need to check is absolute of z is bigger than z of alpha upon 2. This is what we need to check, isn't it? So this value, if we read from the table, this value is 1.96. Okay, so observe what is our z value minus absolute of this quantity is to be compared with this one, so it is bigger. Okay, so if it is the case, what should we do? We have to reject null hypothesis, hence reject h naught. So when we reject h naught, of course we are going to accept the alternate hypothesis. Therefore there is a significant difference between the mean lifetimes of the two brands of bulbs at 5 percentage significance. This is very important. We are testing for the 5 percentage only, not for 1 percentage or some other thing. Okay, and this is another problem which okay, here they have said that the sample size, so it is going to be our n1 and this is n2 and this is x1 bar and this is x2 bar. Okay, and this is s1 and this is s2, random samples and drawn from the two country gave the following data related to weight of all adult males. Okay, now test the significance. This may be the question. Okay, what should we do? We will have to just do the test statistic, that is x1 bar minus x2 bar divided by under root s1 square upon n1 plus s2 square upon n2, and here we have minus delta, so this is 0, of course. Okay, so when you substitute the values and calculate, you get this quantity. And from the table, we read Z alpha. Okay, here supposing we consider the alternate hypothesis. Let us take H naught to be mu1 minus mu2 equals 0 and H1 is mu1 not equals mu2. So in this case, you will have to read Z alpha upon 2 from the table. Okay, so it is again 1.96. You just compare these two things. Okay, so your absolute of Z is 0.918, which is not greater than your. So what do? We just accept the null hypothesis. That's it. So in the upcoming video, we are going to discuss the same thing. The inference concerning 2 means when a small sample is taken. Okay. Thank you.